Oh, this is what my double looks like. Okay, that's something else, huh? Aw, geez, Rick. Well, I don't know how much. We'll try to do it like that. Hold on. Ah, geez, I did not expect any of this, Rick. That's amazing. Here's my face. Can't really do much there, can we? Maybe I could just impose my, because now I'm like double streaming to the phone and whatever else. So, maybe if I could have had like two inputs, I probably could have done it better that way. So let me figure out how to get my screen to fit. I don't want this screen. Can I just duplicate that? Ah, geez. Well, I didn't mean to do that now. Hopefully I didn't mess up the other side. This needs to come forward, which is like right there, right there. Yeah, this needs to come up ahead of everything. All right, well, I guess it's just me figuring out how to do this. And I need to make sure that it comes forward. How did we do this again? Ah, geez. Group. It's not group. There's a way that we can bring this sucker forward. And that's what I need to do. I need to bring it forward. How did I forget how to do all of this, dude? Anyway, that's like really annoying, bro. Hyphen horizontal, hyphen vertical, lock source, okay. No, there should be an option where it's like, all right, bet, do you want to put this hoe a little more forward? And I'm like, yeah, dude, of course, that's what I live for, you know? So allow me just a moment here to figure that out, because that is wild. So as you can see here, I am trying to, oh, we got two, let's go, baby boy. I don't know what you are, but I gotta learn how to hide you. You're not doing me anything. So I will do it like this. Look at that, it worked out after all. And this one will be the second half. And then my face, if we can figure out how to get my freaking face on top, dude. That's so annoying. There's the monitors. Okay, that's my face. I see. We're gonna put me at the very top. Vámonos. Allons-y, allons-y. Let's go. I did it. Um, I'll leave it. I'm just trying to understand here. So I didn't know that I had a dual output. Hopefully there wasn't like some subscription that I signed up for that I wasn't aware of. Allow me just a moment. So much space for activities, right? Let me turn off this light while I'm at it. Maybe it'll help with that contrast a bit more. Turn the red on in that bit. All right, bet. So I'm running this dual setup on Steam Labs and Streamlabs. One is going to Twitch, one is going to YouTube, one is horizontal, the other is vertical, as if it's on my phone. So not sure whichever platform I'll be looking at this on, but it'll be fun to check out in the future. So I'll put this one right here. And I'll put this. I don't know what that is, bro. Here, we'll put that right there. This is cool to do for like, I don't know what else. Put this one over here, a little staggered off to the side. Actually, I'd probably want to stagger it this way. I don't want to have that screen showing. Kind of seems like it's a little confusing that way, right? And then I'll put this one to be over here like that. Great. And I will likely use this thing more often than not. Depends on where I put it. All that matters. And then I'll put my little face over here. Like in between those two spaces. I don't think I'll be using it. All right, I think I've completed my vertical and horizontal setup. So what I'm doing here is I'm in a stats class. I haven't played games in a while, so I was like, you know, what will probably keep my pants tight is doing this kind of stuff, and might as well just record it. And I got extra, I guess you could say I got like extra horny over the idea of doing this because now I see that there's two outputs and I never would have paid for it. So if this is a trial run, I don't want to pay for it in the future. I don't see any appeal to it. So let me get down to the books here. This is going to be a very fun, very engaging class stream. I'm going to be using this time to, um, you know, get some stream time in and also do some homework. Thankfully, I finished everything that was due for today. I'm moving on what is going to be due in a few days, but I shouldn't be playing off due time. I should be playing off the test time that's coming. All right, in this little video here will pop up from time to time. This is when I struggle to figure something out. These are like those little helpful videos, which you'll see right here. See video 1, help you out. What? Well, let's say they better not be able to.
In this video,
dang.
we'll look at practice problem 2 from
Let's make sure
experience
this is actually coming
14
through the.
into a spreadsheet.
I don't think this is coming to my ears.
Once the data is in the spreadsheet, select the data,
you can still hear it.
insert.
Great. So I just did this one. I'm going to go through the ones that I just did and we'll go on the answers from there. I think I like it better with the test on this side. And then we could put that whole thing right there. Whole thing, that whole thing. Question 1, scatter plots. Also, this is going to be great for me because I'm going to be reviewing my understanding of things and hopefully this helps reinforce. So we're dealing with scatter plots with the data ahead of me. And we were to match or figure out which one made sense here. Which explanatory variable has a stronger relationship with the responsible variable of y? Well, you could see that there is a trend happening and it's a positive trend. And because there is a trend happening, that positive y, or I'm sorry, that will represent a positive strong relationship or a correlation. Whereas if there was no correlation, it would have just been scattered all over the place. That being said, the second variable, w, has a stronger relationship with the response variable of y. And I want to make note of how attentive, or rather how, I don't want to say like present or aware or sharp, astute. It'll all make sense later, but I just want to bring attention to this point because here shortly I'll put a pause and I'll come back and there's going to be a noticeable change. It's also going to be like a fun way for myself to determine how much the good stuff, Zaganj, really affects my ability to learn things. Part of me likes to say that, hey, maybe a couple of hits and diving into the math homework will do me well, which I've experienced that and completed assignments and actually had good good memory on some things, some questions. And then obviously the opposite. I've had it where I just couldn't handle it, get sleepy, get tired, so on and so forth. So allow this video to also be kind of layered with purpose. Okay, so we determined that one. Moving on, mister. Question number 2. You want to know how many? Out of how many? God dang 100. I answered 4 already. 4 stats. What's the probability that I'm going to finish this assignment in 2 hours time? And when it took me about an average of 3 minutes per question. I also appreciate that the questions she's starting off with, they correlate, they're like linear, I guess you would say. It like matches one for one with the progress that we've made. So jumping all the way to those earlier questions, man, I'm yapping like crazy. Jumping to these earlier questions just really like requires me to dig deep, especially because like the harder stuff that I was learning, which I think probability was probably the hardest for me to kind of grasp because it took me so much time. I probably had to make space. All right, so we got done with the scatter plot one. I yapped like crazy, barely got past the first question, so I'm gonna shut up now. in the sense of yapping. Here's a scatter plot for a set of bivariate data, and how would you estimate the correlation coefficient to be? Just to make sense of what I saw and how I got this answer was that I see that it's scattered in a lot of places. Although it may look like it doesn't tell a story, it does. And that story showing like some sort of trend moving upward. I like to kind of stare at the center of the cross and just kind of let my eyes relax and just kind of see where the trend goes. I can't make sense of it, but my eyes just are able to. So I can tell this is a more obvious one, but we'll get to one where I had to utilize that method. Um, See that there's a trend. So the closer to zero it is, the more scattered it will be, and the closer to -1 or 1, the more absolute, the more fine it will be. Again, if it's a -1, it would go downwards. If it's a +1, it goes upwards. So because we are trending up, it's going to be positive. And why 0.6 and not 0.9? Because if it was 0.9, it'd be a tighter one. It would be closer to 1. And 0.6, it's not so much, but enough for you to see what it is. Question 3. Match each scatter plot shown below with one of the 4 specified correlations. Here are the 4 options we have: 0.98, -0.01, -0.06, and -0.98. You can see the 4 examples here, right? That's pretty kind of neat to see 2 different streams. Right off the bat, you can see like this is going to be one that's going to be closer to +1, and right off the bat, you're going to see this is something that's closer to -1. And you can see we have those 2 options here, which that's what I put. And we are scattering. This is where I was talking about like the scatter can look a little goofy, but the correct answer was -0.01, whereas this is clearly C, -0.06. And again, the closer we are to 0, the less of a story is being told, right? So that's how we got that. Question 4. All right, this is where I had to pull up my spreadsheet. What the? Oh, question 4. There we go. I was about to crash out. I've been having problems with Excel, so it's just been like pissing me off, dude. So I have here the temperatures. The question isn't. I think this is a bad habit of mine. Is I kind of just look for little things. I'm like getting used to patterns as opposed to actually understanding and comprehending. So I need to comprehend. But the pattern that I saw here was I saw the y plus the x, and then I saw the chart, which were called a memory of mine. That was here. Let me delete this so I can recreate it. It's always good, right? So I just copied and pasted the values. I didn't do anything besides highlighting them all. I went to insert and got dang 47. I went to charts, hit that hoe, scattered it. Didn't get much besides having to double click the little highlighting things here, right click it, went to add trend line, make sure it's linear, and I guess that doesn't matter, but we want to display the equation on the chart. Once that equation is displayed, you can then go ahead and take all the necessary information you need and plug it in. So you can see here that those numbers are what I have here, and cette voilà, tu sais parfait. Question 5. Now we are actually diving into some problems, one that I haven't solved. So now begins the struggle. I'm going to do a handful of questions, and then I'll put it on a brief pause, run that experiment real quick, come back. Let's see if we can notice a difference. So annual high temperatures in a certain location have been tracked. Number 5, yeah, for several years. Let X represent the year and Y the high temperature. At the 0.05 significance level, does the data below show significant linear correlation between X and Y? Caution, this question only allows one try. First, calculate the Pearson correlation coefficient of R, then compare it to the critical value in the R table. So where my mind is going is we want to see if there's a significant correlation. Again, if we see a trend, we're going to see a correlation. So I'm just going to try my hand at this really quick. This is just what my mind was thinking about doing, where it went. And I'm going to go ahead and go with my gut here. And if it doesn't I see almost a straight line. So, and of course, if my gut is wrong, then I feel like I learned best that way. So anyway, we see a straight line, and there is no significant correlation. We are correct. Moving on, we'll make that Q5, right? Q6. There's going to be 100 questions, and I'm going to make a one for each one. Get out of here, bro. Get out of here. Actually, you can't even see the bottom part. There it is. Let's do it like that, baby boy. Baby boy. Yeah, boy. Oh no, not my face. Oh, alright. Beautiful. Oi, Camu, mate. Oh, this is the whole goddamn background of water. Let's do it like this over here. Oh, my mess, dude. There we go. We'll do it like that. Yeah, show me them trees, boy. Like right there. Show me them trees, boy. All right. The following table shows retail sales in drugstores in billions of dollars in the U.S. for years since 1995. Oh yeah, I remember getting this one up. Let Y be the retail sales in the billions of dollars X in the years since 1995. A Lear model for the data and whatever that means. Hat of Y. Oh my days. Bro, this was like chapter 1, it was like chapter 14 because she wanted to get us all horny with like stats. Okay, a linear model for the data is y hat 9.44x plus 84. Use a scatter plot to decide whether the linear model fits the data well. Does it fit the data well? Aw, geez. I don't know, Rick. I don't know, but there's definitely a way that I could tell this if I just paid attention. So we know that this is the x-intercept. This is my slope. That's my x-intercept, or no, I'm sorry, not my x-intercept. Y-intercept is what I was looking for. That's my y-intercept. That is my slope. Then I should be doing a little bit of rise over run over there. So we should be going up about 89. I'm going to go with my gut and say it is not a good. We were wrong. You hate to see it. So let me see if I can make sense of what I'm seeing here. Got it, G. All right, so examine scatter plots show the correlation is significant. We found the equation of the best fit line for the. Suppose you want to estimate or predict the mean final exam score such as 6 students who receive 73 on the third exam. The same exam scores x values range from 65 to 75. Since 73 is between the x values 65 and 75, substitute x equals 3 into the equation. Then, I don't have a feeling that I might have something for this. I probably don't. Let's check it out. I might, but these are more like standard deviations. We're not doing standard deviations. We're not doing relative frequencies either. Frequencies, no, we're not there yet. That's another one. Um, let's continue on. So the equation is okay, so we're just plugging it in. This is call back to algebra here. Over here. Shut the front door. You're telling me that's all that was? We don't know what X is, bruh. Am I gonna calculate the difference between these two? I should have read this. What an idiot. I at least could have seen the point where it crossed, which is right here, and that would have been yes, because look, that matches up with what we're seeing. So this is a good model. We answered that right. Estimate the retail sales in the U.S. in 2015. This I know is not going to be right because it's too easy. The sales are not 222.266 billion dollars. Well, let's find out. To the nearest billion, how about you slobby dobby, my boy? It'll just be 2222222. Here's a shot. I got it wrong. Yeah, I knew it. Mm, year 2015, right? No, no, no. We're getting caught up. That doesn't mean 2015. We're 15 years from that. So I know I'm not doing this right, but let me throw a calculator in this hoe. I'm really gonna like showcase my thought process and all this. I'm gonna look back on it and be like, boy, you goofies, I'll get out. So for 1995 plus the 15 years, dang fat fingers, it's 2010. We're gonna add 5 more years. Is there a trend that I'm noticing? Like, is it gonna be 85, 85, 85, 1? How would we do this? Would it be the mean? No, it wouldn't be the mean. Could I find the difference between subtracting by finding the mean, right? You're adding the highest and lowest and dividing it by 2. No, that's just finding the middle point. Then I would just divide between the classes, right? Not divide, but let's just do 108.426 minus 85.851. Okay, so 225. 220, let's just punch it in here real quick. 575. If I were classier at Excel, I would be using the Excel calculator because it's goaded with the Sawsy Daws, which let me just try it, I guess. Um, let me do it like this. Let me clear out these values. Let me put that, this, like if I were to try to use this, I would do this, make it absolute. Mother bitch. I would put that, would be this. Okay. Plus this, which would make absolute because it would constantly reference it. We hit that. Did I get the value that I wanted? If this is right, which I don't think it's going to be right anymore, then I would progress upwards and have it at 198. How far off am I? Pretty far off. Let me make it. I think I'm guessing too hard now. I need to like not guess and just figure it out. Let me try one more time. Um, Let me do between 85. Mother to bitch. I didn't mean to hit all that. Excuse the language, ho, yo. Um, Time to look at help. Sure, this is what wastes a lot of time, but you know what I'm saying? Do we just read this? Okay. We examine the scatter plot of the correlation coefficients. Okay. We found the equation of best fit line. Okay. We now use the least squares regression line for predictions. Suppose you want an estimate or predict the mean final exam scores. Okay. We received 73. But we don't have data like that we're working with, do we? I'm gonna get pissed, bud. I know it's gonna be much easier than I'm trying to make it. This doesn't feel like it's that. It really doesn't feel like this is that. It's pissing me off, bud. Hey, I'm already crashing out. All right, let's do the video. I'm clearly not comprehending what I'm reading, and also I'm not even reading, so am I really being fair with all this reading nonsense? No! I guess I'll watch a video. Pretty much gives me like one for one instruction, but hey, it's about the journey, isn't it?
We
It's
will learn
why did
about
I
your
not save the white hat, bro? Like, what was I doing with myself? Was I just watching videos, just diddling?
question, and we'll use
Crazy.
Excel to help us with that. Let's begin by reading the problem. The following table shows retail sales in drugstores in billions of dollars in the US for years since 1995. So there you see the column of years
Okay.
and the column of retail sales in
Okay.
billions of dollars. The years are actually not years, but a number of years that has gone by since
Okay.
the year 1995.
I'm gonna get
And
so
this is
mad.
data that is presumably collected from actual things that happened. So 0 years since 1995 would represent the year 1995. And so what we're looking at here is that in 1995, there was $85.85 billion in retail
Don't
sales
tell me it
in
takes
the
you
US.
14 minutes to say this.
And for 3 years after that, in 1998, those pairs of
Okay.
this all fits the data well. I'm going to come up with a number of billions of dollars that we think would have been the amount of retail sales in that year.
Oh, let me
In
see if she
billions
looked
that
at the
we
graph
think
really quick
we
too.
read. Looking at that, so we see that the line looks like it's fitting the point graph. Visually
Yeah.
decide whether the linear model fits the line looks
Okay,
a
yeah, she
good
did
model.
pretty much
We
how I
read,
suspected.
estimate the, so we want to come up with a number of billions of dollars that we think would have been the amount of retail sales in that year, in billions of dollars. So how can we do that?
Billions and
We're going to
billions
use the linear
and
model.
billions.
So here's the linear model, and I'm going to copy
Okay.
that.
Shut the front door.
And then
All
I
right.
also need the year, 2015.
That's your X, isn't it? Don't piss me off.
Okay, so models, the dollars, billions of dollars,
Okay,
T years,
it
F is the number of years
it
after
was the number of
1995,
years,
and F
bro. The
of
moment that she
T
put
is
it,
function notation.
all right. I'm gonna probably shouldn't do this, but I'm gonna do it. I'm gonna say it. I don't care. Mother bitch. Oh, mother bitch. Can't do it that way. So 9.44 times the number of years, which was, what did we calculate? Goddamn 47. 15 times 20, that was 5 more years. So if it's 5 more years than 15, that'd be 20. Yeah, it'd be 20 years. I don't feel so confident anymore. Plus 84.182. Let me just turn this whole thing into a goddamn equation. Hey, how about you suck my typo? Yeah, sure, that's fine. Ain't no freaking way. And look at these numbers. They look like they're gonna make sense. That's gonna get me so hot, bro. This gonna get me so hot. All right. 273. Oh, we got it, Jethro. We freaking got it. Okay. That pisses me off, right? But I cannot. So let's go ahead and do this. Let's take a picture of the question here. Let's get rid of this guy because it did me no good. You feel what I'm saying? Let's do that. Drop him. Quick little reference note, right? And then I need to put that formula right here, which since I can't copy and paste that, I'm going to put this right there. And I want to actually do this, put it up, do that, move it down. Great. Put that up here. Do this. That doesn't mean anything. Get out of my face. X equals time elapsed. I don't know. I'm sure there's a better word. Excuse me. And we're going to use this question for this one. That way when I come back to it, I'll know what it is. Uh, X equals 20. Plugged it in. And this was Y hat. This was Y hat. Great. That's question 6 so far. Use the model to predict the year in which retail sales will be to 34 billion. 234. We just hit 273. And the last one was 222. I am really not supposed to be doing it like this, but here I am. Let's try to say 15, right? Let's see what that does for us. 15 years. Nope. We put 20, right? So let's try. I know there's probably a better way. 18 years. It's getting a lot more specific, isn't it? I already forgot what I put last time. I put 15 years, so let's put 16. 16 years. 16 years. I can't do math right now. 2011, 2011, 2011. Nope, I didn't get it right because that would have been all green. Mother bitch. 2010, you. Did I not put 15? Oh, it's 20. It's 15 and a half, 0.54678. Stupid. Alright, let's go back to the video and see what it smelled like again.
And if you remember that from functions to the as a T no, because those have so cost or fusion. That's what's made them number.
Oh, how does she make that sign?
Form of a millimeter with an arrow. So it's to create
Oh,
a
she just used the
probable.
accents.
That's what we see here. That's what's made them estimation and find out what is the years that have passed since every single cell 19 people. So when I
Yeah,
put in
2015 minus
2015, 20
1995,
years.
it was 20
Before,
years. Time.
go ahead and here.
Why has that?
This just says enter your answers. And we got it right.
Great.
Here's this. If you want, instead of typing in the 20, you could have typed it in this way. 9.44 times this cell, which contains our T value, plus 84.
Yeah, we
then
know
you could
that.
just change the little thing you can try doing.
I see what she's doing.
Now, there is another part to this question. Will be 231 billion.
Okay, here we go.
All right, so we're going to use that same model, but this time instead of looking for the retail sales.
Hold on. That sales number is going to be where the white hat is. We're going to solve for T.
Billions of dollars. Okay. Mess that up. Let me undo it. I'm going to format this as, well, that doesn't really, trying to be too clever. They tell us the number of dollars and billions of dollars, 231 billion, right? So they're actually giving us a Y value, 231 billion.
Okay. Did I not freaking say it? Did I not say it? I know this is basic as shit, but listen, dude. I was going 8 chapters. I just finished 8 chapters. I didn't even write down the time that I finished the other one, which I think was like at 10 o'clock. Completed 2200, which is not true. That sucks. I think I got done like at 10 some change. How do I can't. Yeah. Ugh, no, I'm not gonna deal with that right now. Too much information, you know what I'm saying? Today's goddamn 13th. And streaming. I'll say that. 8 chapters. You think I'm playing, bro? 7 right here. You think I'm playing? What makes you think that I'm playing right now? Because I have 6 right here. All right, you see that 6? And listen, I used to be the kind of student. Look, probability that fucker, this mother trucker was fat. This is a fat packet. I was over here like writing all sorts of notes on the back because I was like trying to make sense. Chapter 5, the thickest. I'll tell you that. Then we had 3 or 4 can't numbers, and then 3, 2 and 1. I don't know what I was doing with my mental state. I must have been like taking a piss. 3, I just happened to have it salvaged and say, all that good stuff. This includes textbook reading along with the vocabulary that she pulls out and some examples. And in the past, I would have never read anything the professor would have told me to read. I would have just relied on their teachings. I know instructions. I don't know. I would have learned that way and banked on it and, blame them if they couldn't teach me because I was hoping they would put more effort. Anyway, I've changed it up because this teacher was like, yo, I want you to read everything, but I don't want you to try to figure that out. You just need to get your brain and eyes used to it. Because I'm doing language learning on my own, I have discovered that that's a very helpful learning method, which is like stop trying to understand everything, just get the eyes used to it and the head and the brain, all that good stuff. And then as you keep going through, you'll gather momentum and just feeling that is great. Chalupe, chalupe. That's all I gotta say. Okay, so why am I over here blabbering and yapping like crazy? My boy, I just told you I recalled something from intermediate algebra. I haven't even started trig yet. I have that next semester. I'm absolutely cooked if this is like what I'm getting all horny over. Okay, let's complete this.
What is the year that this would happen in?
I straight up, yeah, that's crazy.
Okay, so equation and solve for t. So I'm just going to let it be 9.44t. So we're going to actually get t alone, and we're going to have t hat instead of y hat. Okay, your algebra class. Okay, so y here sign you have to make, so just
My
equivalence
dog.
equation.
Stop it, my
Another
dog. I gotta write
t,
it down.
and then
All right, all right, all
is
right, all right. I'm gonna recall this. I'm gonna recall this. Back it up, back it up. We gonna write this down because I'm gonna recall it. I'm gonna recall it, all right? We have what the number is. Y equals 9.44. Let's put T so I don't confuse myself. We know that I confuse myself like crazy. 84.182, right? And then my god dang total that I gotta learn, that I gotta knock out is that we want to know where 234 is in this bit. So we're gonna put 234 in the equation. I got stuck, bud. Alright, let's try this again. Y equals no, 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 no. I'm gonna do it how I understand it. I need to stop tripping. Let's turn y to 0, okay? Because we gotta get t alone. 944. Oh, hell no, did I just say that, bro? Yeah, because we gotta get t alone. I'm not playing with you. No, because our number's right there. That's literally what she just did too, right? And we plug it y. I got this. I got it. 234. Fuck with me. 234 equals 9.44 t, right? Because we don't know the time, but we know what the y is. So why did I put equals after the t? Look how goofy that writing has become already. See how like I had the same thought happen 4 times? You probably couldn't see anything. Oh well, doesn't matter. I'm here to do it for myself, not for you. What's 13 minus 50 equals 47? Uh, I cannot focus, my man. And I haven't even ran my experiment yet. That's 84.182. So what she was saying is what you do to one side, you do to the other. So I'm subtracting 84.182, carrying it around to 84.182. That's a negative plus 234 equals 9.44 time. And now let's do quick maths, right? So where my calculator at, my boy? We want to do 234. I weigh 234 minus, no minus 84.182. ¿Qué tenemos aquí? So we have, which one was the higher? Okay, the positive was higher, so 149. I'm so dyslexic with math and positives and negatives that it kills me every time. 944t. We must get the t or x alone. In order to do that, I'm going to have to divide the t, or 9.44t, by 9.44. So 9.44, do the other side, 9.44. If I did this right, what this calculator will produce will be a quotient that quenches the question at hand. God damn, I'm good, aren't I? All right, so let's write up. So we have 149.818. Let me check the history on that hoe, because that's what we had though. Divided by 9.44. Sweet baby Jesus, please work. 149. I couldn't tell you. Too much suspension. I don't know what that means. I don't know what. Round to the nearest billion? It's round to the nearest year. To predict the year in which. So, which year? 16 years, bro. Did I not say that last time? I said 16 years. It said year 16. I guarantee it. 1995 plus 16. 2011, but it wasn't. Let's do 2010. Final answer. Because it wasn't a full 16. The reasoning was that it was 15. And since it was 15 point something, it didn't surpass 16. So we couldn't say that it happened in the future. We could say that it happened in 15 years and so many months. So if it was saying, oh, where did my other calculator go? Oh, yeah, here we go. If it was saying 15.8, 8, 9, like it was 9 months. I can't divide right now, but it was probably like 15 years and 10 months. You can't say it was 16 years because it achieved that number before the 16. Ergo, 15 years. That's how I got it. So you can see how I was guessing, how she was mentioning in that video. I could have made my own little calculator so I could sit there and keep guessing. My boy, like, why am I sick with the sauce? Hold on, hold on, hold on, hold on. Hold up, hold up, hold up, hold up, hold up, hold up, hold up. Ain't no freaking way, dog. Ain't no freaking way. But if I want point 0.8, there's some freaking way about it. There's a freaky way about it. All right. That's annoying though. It's a good thing I didn't try to freestyle it because I would have definitely not got what I wanted to get. All right. Moving on with the next one. This is way too much. This is probably not as hard as it seems. Okay, so on to the next question. An equine scientist was interested in horse height, measured to the horse wither in centimeters. As a young horse aged from 200 to 800 days, she collected the data in the graph above from records on horses she had worked with in the past, shown by the blue dots, and fit a linear regression equation shown by the red line. Okay, according to the regression equation, um, let me finish these notes here before I move on. Plug to solve. I almost got too horny that I didn't want to do it this way. What's a detailed solution mean? Ain't no way, dude. Nah, cause that ain't right, my dog. That ain't right. Mm-mm. Okay, that should work. We'll go on to Q7. Pretty sure I'm gonna need it for this. Already 40 minutes, dude. Studying math, like I get into it, because I don't feel that I've wasted 40 freaking minutes. I mean, when I realize the time, it gets kind of annoying. It's like, geez, man, it passed that fast. But like, that's how engaged I get with this stuff. Um, doesn't necessarily mean I understand it though. So, all right. So according to the regression equation, as the age of the horse increases in days, the wither height in centimeters increases. I guess, my man. The age of the horse in days and the wither height in centimeters are positively correlated. If that's a question. Hey, look at that. The slope of the regression equation is approximately getting 5% and some change. Interpret the slope by completing the sentence below. Okay. As the as the age of the horse in days increases by 1, the wither height increases by 0.054. That's not right. Fucking knew. Oh! Hmm. It increases by the slope. That's that. That's that noggin, boy. That's that noggin. Increases by that goddamn slope. What you had thought I was talking about? You thought I didn't have that? Okay. I had that from the get, goofy. The regression equation approximates the wither height by the following formula. Let D's nuts equal age in days. Let W, George W, with wither height in centimeters. So, wither height was a callback to that last problem that we just had. Use this equation to approximate the wither height of the horse that is 530 days old by completing the sentence below. Slobby the knobby, my boy. We gonna do this the way that we just did the last one. The regression equation estimates that a horse that is 530 days old will have a wither height of these nuts. All right. So I think I just like algebra way more than statistics. They say statistics is easier than algebra. Honestly, like I don't know. I really don't know. I think the more words involved, the harder the math gets. Because when you have formulas, when I start getting to like the formula stuff later, I won't do it in this stream because I'm not doing this whole thing in one stream. Um, but later in these streams, I will likely be like, oh, equations, I got that. Excuse me. So we have 0.054 times. No, we're still okay. What the heck? I thought I saw something. 530 plus 119. 195. Okay, that's just a straightforward equation right there in front of my face. I don't know why I just type it. 054. We have to put the times for this, which is going to be 530. And then we have to plus 119.195. 147. Oh, yeah, no, that makes sense. Do we have to round to any specific? No, I guess not. Grab that, plug it in here. Yeah, hate to see it. No, you actually love to see it, all right? If you supported me, you would love to see those green check marks and green banners that allow me to get off just a little bit more. You want to talk about natural dopamine? That is real dopamine right there. Solving little micro problems. Nah, that's fake dopamine. The real stuff is just hitting those experiments. You feel me? All right. So an interior designer wanted an estimate of how much paint she needs to cover a varying amounts of square feet. Oh, dude, I remember this one. She collected the data in the graph above from previous projects she worked on, shown by the blue dots, and to fit a linear regression equation. According to the regression line, as the number of gallons of paint increases, the number of square feet painted increases. because we have a positive correlation, positively correlated. The slope of the regression equation is approximately 401. 401 is going to be going as the increase by, so we got to interpret the slope below. As the, didn't it just tell us this? As the number of gallons of paint increase by 1, right? Like, isn't that just pretty much, that's like the same thing. Then the numbers of gallons of paint, the number of square feet painted increases by 401. I'm not gonna hit enter yet, although I really want to. Oh man, I remember getting this one wrong. Okay, let's see if I have, let me see if I'm him. All right, let's see if I'm him. I will go off if I get this right, because I do remember getting this wrong. All right, let's go. If we have 0 gallons of paint, 0 gallons of paint, we can paint 0 square feet. The vertical intercept of the regression equation says that if, no, says that, I'm guessing that's supposed to be if, we have 0 gallons of paint, on average, we can paint approximately 14 square feet. Some typical reasons for this disparity are because those aren't finite numbers, those are just roundabout numbers. Probability? It's not paint thieves. I didn't answer that last time. I'm not that guy, all right? I'm that guy, but not that guy. Variability in how someone paints. Uh, I don't know. Yes. Measurements. Are they all options? Bro, what? Measurement error. Why? Every normal teacher does 4. Now 8 should be hurting my dick. So we have, it's not black holes. Let's go the other way. I'm going to go the opposite situation. I'm going to complement it, if you will, statistically speaking. It's not going to be paint thieves. It's not going to be black holes. It's not going to be paint mitosis. And what is paint mitosis? What is mitosis? Let's do a quick Goog. Process of cell duplication. Oh my days. I knew I had to do something with the mitochondria or something like that. Um, all right. I know it's not that. I know it's might be that. So I'm going to go based off of how ridiculous these answers are. And obviously because I just know. Variability in paint surfaces. It's not freaking a cell wall. And variability in paint. And the measurement error in paint purchase. These are all variables as to why we can't get it perfect every time. Because there's always going to be that guy. Remember, I'm not that guy. But that guy, he gonna mess up the measurements. All right. Oh, I'm sorry. I bought 5 cans. You needed 7? What do you think I am, a math whiz? Variability in paint. I I guess I won't think too hard about it, but there probably a time where it's just like this one, that one, this one, that one, right? Probably different amounts in each one. Variability in paint surfaces. Word. You could be painting a wall 1 second and painting so much more surface space or surface area along that same wall. And variability in how someone paints. This guy right here. You know how I paint? I can throw buckets. All right. And sometimes I'll use a little paintbrush, painting walls. Am I him? Don't even want to look at the screen. I'm gonna look at it through the stream, guys. You'll love to see it. Hey, am I gonna snap on this test? No, because I've been wasting a lot of time. Imagine this was my actual test. You only have like an hour and 20 minutes. I would have had 20 minutes to get through so many questions. And then on top of that, you know how many times I've used the references here? Him, all right? Okay. Cap this energy though, because we gonna come back. I can't believe that I was going this long. Can't believe I went this long, wasting time. Same idea. Let's push through all of it. I ain't worried about nothing. I shouldn't be like that. Let's go through the freaking verbs. Edge. The amount of ice in Antarctica does change with the weather. There is more ice in the winter when it's colder and less ice in the summer when it's warmer. Okay. However, there have been large changes in the amount of ice due to climate change, which is caused by an unprecedented amount of carbon dioxide in our atmosphere. Those damn liberals, I swear it was hunting Biden. It was hunting Biden. But where were we? The data above approximates NASA's data on the change in Antarctica's mass measured in gigatons relative to 2002, shown by the blue dots, and the linear regression equations shown by the red line. Bet. A metric ton is approximately 2,200 pounds. A gigaton is 1 billion metric tons. According to the regression equation, as the number of years since 2002 increases, the amount of ice in Antarctica decreases. I see now we're going through a negative quadrant here. Okay. Decreases. Sorry. The number of years since 2002 and the change in the amount of ice in Antarctica are, where are we in 2002? Year since 2002. Again, this isn't the end year. This is individual years. Discrete, I guess, years. And you start throwing out the verbiage to make sure I understand the vocabulary as well. So we have discrete numbers. We're counting it. That being said, it has been negatively correlated because they're correlated, but in a negative fashion, my boy. The slope of the regression equation is approximately negative 107. Interpret the slope by completing the sentence below. Easy schmeezy, my boy. As the numbers of years since 2002 increase by 1, the amount of ice in Antarctica decreases by negative. Nope, we don't put the negative in there because it's already it's all they already tell you decreases. You feel me? Come on, you need to start feeling me more. Tired of y'all not feeling me. The regression equation approximates the change in the amount of ice since 2002 in Antarctica by the following formula. Let T be the number of years since 2002. Okay, let M be the change in mass from Antarctica's ice in 2002. Use this equation to approximate the change in the amount of ice in Antarctica in the year of 2018 by completing the sentence below. Hint, for the year 2024, you would use 22 in the formula. Is it because yeah, because there's 22 individual years that add up to 2024 because we're starting in 2002. The regression equation estimates that in the year 2018, the change in the amount of ice since the year 22 will be. The regression equation, so we got to figure out what 2018 is giving us, and then we have to find the difference between the starting number and the 2018 number. Why do I have a fat feeling that this question is that I'm complicating this? I have such a fat feeling that I'm complicating this one. All right, so we did. What was question 7? Whatever. We're going on question 8. It'll make sense whenever I refer back to them. And we're on question 9, by the way. So we didn't have to work an equation until like right over here. And I don't have a number for 2002. We have a starting number, right? No, we don't have a starting number. So 2018, we don't know. So 2002 is a starting point, which we're essentially starting from 0. So if that's the starting point, so the difference would just be whatever that number is. Okay. So 2018 is the time. What's the time between 2018 and 2002? So we want to figure out how many gigatons that is. We'll put M equals. Let me put it on the dang sheet over here. I'll put. Screenshot this. No, we won't screenshot that part. We'll screenshot it afterwards. We'll do M equals negative 107 times 2002 to 2018 was 16 years 16 years without even a place to call my own. We're not going to put the plus. We're just going to put that. And then we get 1826, an absolutely phenomenal year. I'm not going to put any negative in there, right? Freezing ice will be 1,826 gigatons. Do I think this is the answer? Yes, Jethro, I do think so. Ah, mother bitch. What did I get wrong over here, dude? It was the last part, dude. We did 16 years. And we did, it's in gigatons, isn't it? It's in gigatons, boy. Ah, dude, I felt so good about all this progress. The regression equation estimates that in the year 2018, the change in the amount of ice since the year will be negative. Did I forget the negative? Because there's nothing indicating a positive or a negative in the words. So let me throw it in there. See what I mean? I could have been him, but I had to be him. All right. I'm gonna throw it on hold, and I'll be back with it. Gonna start that experiment, if you will. whole lot of cool stuff. Whole lot of cool stuff. Um, let me let a little essay in. That's little Rams. Hold on. Do you see him? Come here, boy. Come here, little Rams. Oop, poke his eye with my knife. Sorry, boy. Come on, boy. All right, go to sleep, boy. My doggy. He an old man though. Let me give you a math problem. Our dogs are like 7 years. That boy been here since 2012. He an old man though. I can see why this class is hard, honestly. Remember I was saying like, ugh. Here, I'll read off the text messages. Hey, I'm messy as fuck, huh? I'm gonna read the text messages of the people in my class. I'm not putting any names, but I'll read you just like how everyone's feeling about it. And would I say I would sympathize? I think I empathize with them. Like I get why they would feel the way they do. Damn boy. So someone put what in tarnation? Hi everyone, I'm scheduling an appointment for test one, but I'm not sure which instructor exam I'm supposed to select. That's crazy. Would anyone know which one it is? XB, X, uppercase X, lowercase b, closed eyes, tongue out. I feel like this guy is my age, if not older. I emailed her about it. Oh yeah, reciprocated. Same, it's same. It's XB all uppercase. Thank you. Anyone ready for this? Cause am not. What can we write on the 5x8 card? Which this person's. I guess anything we want. LOL. I'm not ready at all. I'm catching up on assignments right now. Module 6. Module 6! Yo, cooked. Well, on the bright side, that information is going to be relevant for them. I knew I sounded let me turn on my gosh darn. She going so fast I lost all the past info in my head. Ain't that the truth? But to be fair, this is an express class. Z-score now normal distribution. Explosion. Yeah, it's hard. I'm already taking 3 other classes. Yeah, I got anatomy 1 and lab 2 papers. 10,000 words due next week. Tough. He also has a dead mouse. That's another reason why I think he's my age. Like, what person listens to dead mouse anymore? I guess a lot of people. Let me fucking look that up. At least on Spotify. Speaking of samples. The fuck was I talking about, bro? Dead mouse. Dead mouse 5, bro. Never mind, my man's got 5 million listeners. Definitely not popular. Um, yeah, but that's what I mean though. I get it. I have the luxury of just essentially taking 2 classes, whereas these other cats are like full time. Bitch. Okay, let me resume. We gotta hit next page. Oh. Well, I just was too far down. I was like, what in tarnation? Okay. Determine what the key terms refer to in the following study. A study was conducted in a local community to analyze which voters would be likely to vote and how on an upcoming board. Bond. Oh, jeez. Voted, didn't vote, voted. That's data. Oh, man. Oh, jeez. All eligible, all eligible voters in the community's got to be the parameter. No, that's the parameter. The population is just everyone. This is which one? All eligible. I thought it was just all eligible. Yep. Is the variable the attendance of a single voter? Huh. Maybe that statistic. What does that leave me with? Maybe C, D, no D. D is the number of eligible voters in the study who actually plan to vote. D was the parameter. B was the number of eligible voters who plan to vote. What? Hmm. All right. I'll do one more review, then I'll jump over to read. All right, so the voted didn't vote voted. That's data. The parameter I'm saying is the number of eligible voters in the study who actually plan to vote. That's the parameter. Who actually plan to vote in the study. In the study. Okay, the number of eligible voters who actually plan to vote. That's got to be D. Yes, all right, that makes sense now. F, sample, a group of voters in the community who voted randomly selected. Sample, statistic, the number of eligible voters who actually plan to vote. I guess statistic, I'm thinking the attendance of a voter. So then that would mean that the variable is B, the number of eligible voters who actually plan to vote. Because they vote or they don't vote, right? So if it's the variable. Let's just take a guess. Mother trucker, dude. Which one did I get wrong? Alright, time to read. What? What was I even looking for again?
In this video, we are asked to determine what the key terms refer to in the following study. A study was conducted in a local community to analyze which voters would be likely to vote and how on an upcoming bond. And we are given the terms here: statistic, population, parameter, variable, sample, and data.
Yeah, some.
Then we have the definitions that we're supposed to match with those terms. A, voted and didn't vote. B, a group of voters in the community who voted randomly selected. C, the attendance of an individual voter. D, all eligible voters in the community. E, to develop the statistic would be a measurement that comes from a sample, while a parameter would be a measurement that comes from the entire population. So if we can identify anything that would appear to be a measurement or a count of some kind, something quantified, a quantitative number, or some sort of metric, then it'll be one of these two, and we just have to decide which one is for the population, which would be a parameter, or which one is for
Word.
the sample and make it a statistic. Okay, so I'm going to zero in on the ones that say the percentage of, because those are metrics or measurements, some kind of quantity referring to either the sample or the population. Now, let's read these two again. The percentage of eligible voters who actually.
I legitimately can't follow, and I'm gonna get to the point where I'll just rush to the answers and then skip on and not learn what I have to learn. So, that being said, it's a good stopping point. I don't have to come back at it again fresh. Still have time. Well, I'll run that stream next time, I think. Alright, time to review the review.